All right. Good afternoon, everyone, and welcome to our Safer Sim webinar series. My name is Jacob Hayden, and I'm the program coordinator for Safer Sim at the University of Iowa. Safer Sim is a Tier 1 university transportation center with the research priority of promoting safety, and our webinar series features the research projects from within our center. Thanks for hopping on today. There will be time at the end of the presentation for questions and discussion. Attendees can use their microphone or chat box to participate. So feel free to use your chat box at any time throughout the presentation as well. We will hold those questions for the end though, whenever they come in. This webinar is being recorded and will be shared online afterwards. And with that, I would like to welcome our presenter today from the University of Central Florida, Lishengsa Yu.
Thank you, Jacob. So, hello everyone. Our research is about investigating the effects of smartphone-based P2V warning using driving simulator experiment. The pedestrian-to-vehicle warning, or we call it P2V warning, is expected to reduce the pedestrian crash. The basic idea is that we use some telecommunication devices to broadcast a pedestrian's location to nearby drivers, so that the drivers can be alert if there is a conflict risk. The widely used smartphone can be such a communication bridge between a pedestrian and the driver. A pedestrian can upload his or her location to the cloud database, and any driver who subscribes that the cloud can be updated about the pedestrian's location. Such smartphone-based P2V system can be particularly useful to prevent pedestrian crashes in those scenarios such as a driver's side of view is obstructed or the driver is distracted and fail to observe the pedestrian in time. When we put the smartphone-based P2V warning into the practice, we may have some concerns. The first concern is we would like to see whether the warning would be efficient in different scenarios. There are many studies have pointed out that the traffic complexity, such as speed limit, roadway facility type, can affect the pedestrian warning's effectiveness. The second concern is how we should design the warning content or the warning timing in different scenarios. What type of information should be delivered to the driver, and when should this information should be delivered? The third concern is whether different drivers would be affected differently by the P2V warning. Therefore, the purpose of this project is trying to investigate these concerns. We developed a simulator platform which connects the driving simulator and the smartphone. Here, we use an iPad instead of a real smartphone because their function of the experiment is to display the warning information. In other words, we focus more on the warning design rather than the hardware side. But we did simulate the communication process of a typical smartphone-based P2V warning system. We broadcasted the information of a pedestrian to the Redis database and calculated the conflict risk on the cloud, and then a driver subscribed this Redis database would receive the warning information through the local iPad. In our experiment, we test the P2V warning in 6 typical pedestrian pre-crash scenarios. The first scenario is a pedestrian who walks from behind an adjacent car. The second scenario is a pedestrian suddenly walks into the road without showing any crossing intention before. The third scenario is a pedestrian who walks from behind a right turning car. And the first scenario is a pedestrian who walks from behind some bush. The fifth scenario is a pedestrian who walks in the road and hit by a car's side mirror. We arranged 2 sub-scenarios here. In the first scenario, sub-scenario, the pedestrian keeps 1.5 feet distance to the road curb, while in the second sub-scenario, the pedestrian keeps 3 feet distance to the road curb. The sixth scenario is in a normal pedestrian crossing scenario. We tested 2 types of P2V designs in this experiment. The P2V warning design tests 2 issues. The first issue is the warning display mode, whether gradually change the warning. That is to say, the warning color changes from the white to yellow and the red based on the situation severity. And the beeping audio is also changed from a slow beep to a quick beep. Whether this type of gradually changed warning design is better than an emergency warning design. So an emergency warning design is to say once the warning is activated, is exactly at the timing of a red warning icon. The second design consideration is about the warning content, whether some additional information can assist the drivers in making decisions, such as if the lateral distance information or the crossing intention information of the pedestrian. In scenarios 1, 3, and 4, we tested the difference between a gradually changed warning design and an emergency warning design. And in scenario 2, we tested if we provided the crossing intention of a pedestrian to a driver, would this be helpful? In scenario 5, we tested if we provide the lateral distance to the pedestrian to a driver, would this can reduce the pedestrian crash? And in scenario 6, we tested if we simply provide the pedestrian's distance information to a driver, whether the driver would improve his braking judgment. We made the experiment to build with in-subject design. So in total, 36 participants took the experiment, and we collected over 15 variables to measure the driving performance as well as the safety level. From the results, we can see that in scenarios 1 and 4, the emergency warning design has a higher collision rate than the gradually changed warning design. This might be because the gradually changed warning design would help the drivers make gradually adjustment in terms of deceleration or lane change to the upcoming events, and they do not need to take aggressive evasive actions in a very short time. In other scenarios, no significant difference was found between two types of warning design. In terms of driving behaviors, in scenarios 1 and 4, that the brake reaction time and the throttle to release time was significantly larger in the test P2V warning design than the base P2V warning design in these two scenarios. And the scenarios 1 and 3 had a larger brake to maximum brake time, and the scenario 3 even showed a larger brake reaction time. Here we highlighted these scenarios because the statistical results were significantly at 95%. So for these types of scenarios, the test of P2V design, in other words, the gradually changed P2V warning design, provides a driver with sufficient time to figure out what and where is the dangerous source. And this might make a driver feel more comfortable compared with directly push a driver stop order without having let them know what is happening. In scenarios 1, 3, and 4, the mean deceleration, maximum deceleration, and the maximum brake were lower in the gradually changed P2V warning condition than the base P2V warning condition. The result indicates that the driver thought they didn't need to use a hard brake. Therefore, we may think another priority of the gradually changed P2V warning design in scenarios in which the pedestrian is hidden, such as scenarios 1, 3, and 4. So is that the test P2V warning would smooth the driver's adaptation behavior, which can improve the driving comfort. We also found that in scenarios 5 and 6, the throttle to release time was smaller in the test P2V warning design condition than the base P2V design condition. The jerk in the scenarios 5.2, that is the scenario in which the pedestrian walk along the curb in a closer distance. In this scenario, the variables were lower under the test P2V warning design than the base P2V warning design. The reason is that the test P2V design makes the driver become more conservative and alert, even though the driver has no difficulty to monitor the pedestrian, and it may have a better driving comfort by allowing drivers to have more time to adapt to the possible danger. We also analyzed the interaction effects between driver features and the P2V warning. In scenario 1, the test P2V warning design significantly increased the brake to maximum brake time for drivers who had been involved in a not at fault crash before, compared with the base P2V design. This indicates that the test P2V design may be particularly improve the brake performance of drivers who had been involved in a not at fault crash before, since these type of drivers do not have to take a hard brake. For drivers who did not have a not at fault crash before, the test P2V design may improve their driving comfort by reducing the hard brake in scenarios 3 and 5. In scenarios 3, the results show that the test P2V design reduced their maximum brake levels and the jerk compared with the base P2V design. And in scenario 5, the drivers under the test P2V design had a lower throttle to release time. So in scenario 5, the test P2V design, for this type of design, we provide additional lateral distance to the pedestrian. This information will provide this information to the drivers. From this research, we can see that the gradually change the warning P2V warning design. And if we consider providing additional information such as the pedestrian crossing intention or the lateral distance to the pedestrian, such type of additional information in our warning content. By doing this, we can make a driver better adapt to the critical upcoming potential conflict. The effectiveness of the test P2V design could be further improved when considering the scenario and the driver features. So this is an overview of our project. So thank you for listening, and I'm welcome for any questions.
Thank you, Lishengsa. As you mentioned, we do have some time for questions and comments. I will say this report or this project did recently submit their final report, so that will also be available as soon as possible within the next couple of weeks. And I will put in the word for our next webinar too. We do have a couple weeks off, but our next one will be on Tuesday, June 22nd, and that features a project from the University of Massachusetts Amherst. So we will send that registration info in the next couple of weeks. And with that, I'm not seeing anything else, so I'll just thank you all for joining. Thank you again, Lishengsa, for the
Thank you, Jacob.
presentation. And we look forward to seeing everyone at our next webinars.
Thank you.
Thanks.